So in this class, we're going to discuss about the Diffie-Hellman key exchange protocol. It is one of the public key, so key exchange protocol. How securely the key has been exchanged with the user one, the user two, we can get back. And so examples of this key. So Diffie-Hellman, it is not a public so encryption and decryption algorithm. It is a so key how securely exchanged with the so two communicating parties, user and user two. So we have to discuss about this algorithm. So here two end users can agree to share the secret code without any information shared in advance. So without the information is shared before and well in advance. So the two parties, two communicating parties, user one and user two, securely they exchanging the secret code or secret keys. So without information has been changed in advance. So exactly exchanging the key. So that is exactly the algorithm. So that is invented by Diffie and Hellman. So that is so popularly it is a asymmetric key exchange protocol or algorithm that has been invented by two scientists, Diffie and Hellman. So this protocol is normally used for so virtual private networks. In virtual private networks, it is one site is located in one location, other site is located in other. So that is a site or location. So how securely exchanging the so without well in advance for the one location of computers with the other location of the computer. So secondly, so exchanging well in advance without information is shared in advance. So securely exchanging that. So that is a information here. It is a so in the VPN networks, how securely exchanging through the public networks using the public communication networks only. How their virtual so that is virtually so private networks have been connecting. So the one private networks in one location, another private in other locations of the same city, or it is a different city how they have connectivity can establish their computers with so one location computer with the other location computers, how they're exchanging the information securely over the so public network communication networks. So that is what we call as virtual private networks. Assume that user one wishes to communicate to the user two, so without the sharing of so any prior information, so well in advance. So how securely they're exchanging the information. So with the help of this Diffie key exchange. So how key exchange is shared securely. So with the following the algorithms has been explained. So the key generation algorithm. So your user one select the again prime numbers A and random integers x1 and generator g and creates a y1. So that is a y1 is such that y1 is a so g to the power of x1 and mod a. So that is they do the computation by so user one. So select the prime numbers. So a is the prime numbers. That is exactly they are taken as a mod a and g to the power of x1. So that is x1 is a generator they are taken here and it is a user 2. So whenever the user 2 it is perform the same function and it is create a y2. So y2 will so it is a create and such that so that is a generator G. So G is the generator here. So G to the power of x2. So x2 is the so it is exactly random integer number they are taken and mod with the mod operation will perform with that. So it is a prime numbers whatever the prime number has been selected here. So that is done by the user two. So user one is doing the so same so that is the steps and user two is also doing the same steps. User one then sends so it is a so y1 so to the user two. So user one so will send so the how securely so whatever is calculated y1 value how it is send securely to the y1 so to the user two. So this y1 has been sent to the user two. Now user one so forms its key whenever it is sending these y1 calculations g to the power of x1 mod a. So it is a so key is so form that is a key. So is before sending that key will be formed so to do the some encryption techniques and what is the key so y to the power of so that is a extra x1 and mod a key one is generating like this information its partner as a sign so key is generating k1 is equal to y2 so x to the power of so that is a always it is using so that is exactly so y to the power of x1 and mod a and the user two forms so key so while using the information to its partner that is a user so one and send it as so whenever sending the so information or data key k2 will form by the user 2 so y1 to the power of x2 so that is a mod a. The two keys are equal k1 and k2 because if you deduce back. So just apply back. There's definitely K1 and K2, both keys are equal. So it is a y to the power of x1 mod a. So this is the K2 is y1 to the power of x2 mod a. So both are equal. The two users can now encrypt their messages using these own keys. So they're exchanging the messages very securely. So keys are exchanging. So that is securely. So this is how the calculations is exactly going on in the DP exchange algorithm. So in this class, we have discussed about DP-Hellman exchange protocol. So and so that is some examples which are so you can refer to the textbooks. That is examples also be available. So again, so that's all about this class. So DP-Hellman key exchange protocol. So it is not a public key and cryptography. So that is methodology. Here, encryption decryption will not done. Only it is a so it is an encryption, so key exchange protocol. How securely exchanging the key by the user one and the user two.